So let us now continue about Archimedes principles. So the word buoyancy and Archimedes principles, they are interrelated to each other. Eureka, Eureka, I found it, I found it. Okay? That was a well-known expression, taken out this context coming from Archimedes principle. So, why is this very important? Why is it very significant to our study when it comes to mathematics and physics? So Archimedes' principle states that the body full or partially immersed in a fluid is buoyed up. So there is an upward force. Remember that buoyant force is always been an upward force. A force equal to the weight of fluid displaces. So an object lowered into a fluid appears to lose weight. So the force that causes this apparent loss of weight is referred to as buoyant force. How does this equation happen before? So the buoyant force is considered to be acting upward force. Means to say it is a pressure, the reaction force from the fluid component. Okay, as I've said, I mentioned earlier, like when we are swimming at the pool, at the sea, or in the river, right? So there is always a reaction force towards your body weight. And there, okay, if you are expert in swimming, so you will know how to resist the force against the water. So the buoyant force is considered to be acting upward through the center of the gravity of a displaced fluid. So remember that your body weight acting with gravitational force or body weight. So considering that your buoyant force, okay, the buoyant force itself, okay, contains with the mass of the gravity, okay, with the fluid pressure or density, okay, and its gravity. So the pressure difference between the top and bottom of this object must support the weight of the fluid that would be there in equilibrium of the object. We're not there. So the pressure difference between the top and the bottom of this object must support. So according to the given component. So another thing, in general, the object floats in a fluid if its density is less than the force of the fluid. At equilibrium, when floating, the buoyant force on an object has a magnitude equal to the weight of the object. Means to say that by the time the objects immersed on the water also reacts. That is why you observe, once you put a stone or any object in a glass of water or in a basin with water, the water level rises. It is because that is a fluid that is being displaced at that moment by the time when object starts to immerse in the water. Okay? So that's the way how the buoyant force creates its own pressure as part of the reaction force towards the object that we are using. So the buoyant force due to a fluid, the fraction of this, as you can see, try to observe the fraction of the floating object that is submerged should be equal to the ratio of the density of an object to the fluid. So, in this case, for example, okay, An aluminum object has a mass of 27 kilogram and a density of 2.70 times 10 to 3 kilogram per cubic meter. The object is attached to a string and immersed in a tank of water. Then determine the volume of the object. Now, what is that? Okay. The mass is 27 kilogram. Okay, the mass of aluminum. Then the density is 2,700 kilograms. So why instead of 2.70, you have to multiply this one, okay, into 1,000. Okay. Then the density of water, okay, which is immersed, 1,000 kilogram per cubic meter. So we need to find the volume of aluminum and the mass and the density is there. So therefore, 27 kilogram divided by 2,700 kilogram per cubic meter. So your answer should be 0.01 cubic meter. For letter B, determine the tension at string when it's completely immersed. So for example, with this one, okay. So the volume of water and is equal to the volume of aluminum. Then the gravitational force of water, okay, water density and volume of water times the gravity. So we already have the density of water is 1,000, okay, kilogram per cubic meter. Then the volume of water is already given 0.01, okay, as the volume of water. And then 9.8, it is a constant value of gravity, 9.8, okay, meter per square seconds. So therefore, the result is, okay, the complete tension of this, the volume of water, okay, and the gravitational force of water will be 98 Newton. So therefore, buoyant force is equals to gravitational force of the water. So this could be like this, and this one. So gravitational force minus buoyant force, 27 times 9.8 minus 98. Okay? So what will be the result? 166.6 Newton. No? As its, okay, the force, no? The tension force of this aluminum. Then a piece of alloy has a mass of 86 grams in air and 73 grams when immersed in water. Find its volume and its density. So the mass of alloy in air is 0.086 kilogram. And then the mass of water is 0.073 kilograms. Then the density of water is 1,000, okay, kilogram per cubic meter. So therefore, we need to find the volume and density of alloy. Okay? So let's find out first, buoyant force is equals to gravitational force minus apparent gravitational force. So 0.086 times 9.8, okay, minus 0.073 times 9.8 again, because this is all about gravity. We need to attach the constant value as always. So therefore, that will be 0.1274 Newton. Okay? So the buoyant force is equals to the density of water times the volume of water times gravity. So therefore, to find out the volume is equals to the buoyant force divided by the water density times gravity. So therefore, buoyant force divided by the pressure of water and the gravity. So the buoyant force there is 0.1274 divided by 1,000 times 9.8. So the result would be 1.3 times 10 raised to negative 5, or power of negative 5 cubic meter. So this will be the result. So therefore, we need to find out the density. Density, remember, our constant equation is density is equals to mass over volume. Okay? So density is equals to mass divided by volume. So therefore, the mass of this one is 0.086 divided by 1.3 times 10 raised to negative 5. Then the result would be 6.6 times 10 raised to the power of 3 kilogram per cubic meter. So this is the how are we going to get now the answer related to this one. Okay. Then a solid aluminum cylinder with density of 2,700 kilogram per cubic meter has measured mass of 67 gram in air and 45 grams when immersed in turpentine. Find the density of this turpentine. So this one, density of aluminum 2,700 kilogram per cubic meter. Okay. Mass in air 0.067 kilogram. Then mass in water 0.045 kilogram. So buoyant force equals to gravitational force minus apparent gravitational force. So gravitational force 0.067 minus 0.045 times 9.8. Then to find out, that will be 0.156 Newton. Okay? So what about the cylindrical volume? Okay, cylindrical volume is directly proportional to the mass over the density. Okay, so 0.67 divided by 2,700, then the answer is 2.48 times 10 raised to negative 5 cubic meter. Okay, so this could be the final answer related to this one. And what about, okay, the turpentine density? So density equals to mass over volume. 0.2156 divided by 9.8, then divided by 2.48 times 10 to negative 5. So the result would be 887.1 kilogram, okay, per cubic meter. So these are the following examples of problems on how to deal with about the density, okay, the volume of liquid, and of course, the buoyant force and its apparent weight as well. So in this case, about Archimedes principle, which Archimedes emphasized, he stated that the buoyant force of an object, again, in a fluid is equal to the weight of a displaced fluid. I'll repeat. Archimedes stated that the buoyant force on an object in a fluid is equal to the weight of the object being displaced. So in our example, supposed to be a block displaced 250 ml of water. So the 250 ml water weighs about 2.5 Newton. So according to the principle, the buoyant force pushing upward on the block is 2.5 Newton exactly. That's in between where the object takes place, the tip end, where the object takes place. And then you can measure that one, okay, that's the fluid being displaced. And that is equal to its buoyant force. So, I repeat, in this case, in 1 cubic centimeter of steel weighs more than 1 cubic centimeter of water it displaces. So it's equivalent. So in this case, it sinks. Well, in 1 cubic centimeter of ice weighs less, so it is pushed up. So according to the Newton's third law of motion again, now let's go back to the third Newton's law of motion. An object pushed back because in every action there is always equal or opposite reaction. Now, according to the third Newton's law of motion, in which this also relates about Archimedes principles. So, what causes buoyant force? So, buoyant force is the upward force on an object exerted by the surrounding fluid. when an object pushes water, the water pushes back with as much as force as it can. Okay? So, if the water can push back as hard, so the object floats